Hi everyone. Today we'll be discussing the LeetCode problem of the day, count collisions on a road. So here you're given n cars on a infinitely long road, numbered from 0 to n minus 1. And each car initially is assigned a direction, which is either left, right, or stationary. So we have some directions for each car. So, and each of this car will have the same speed. So this car has a direction left, so that means this moves to the left with some constant speed. And this car has a direction right, so it moves to the right. And this car is stationary, so it remains there. Here on this infinite road, there can the collisions can happen because this car moves to the right and this car moves to the left. So eventually they'll collide. So when two cars moving in the opposite direction collide, the number of collisions increase by 2. So we have a car moving right and we have a car moving left. And when they collide, since two cars are colliding, the number of collisions is increased by 2. And suppose if a car is moving to the right and a second car is stationary. So in this case, this car uh, keeps moving and eventually collides with this stationary car. In this case, the number of collisions will increase by only 1 because this car was uh, stationary before only. And also after the collision happens, so suppose this R and this L will collide, and when the collision happens, both the cars will stop, so they won't move. So it's not like these both cars will collide and the direction will change. So it's not that. And both two cars collide, they will stop. So we can say after collision, their directions will become like stationary, so they won't move. So at the end, you just have to return the total number of collisions that happened on this infinite road. So let's look at the first example. So here we have 6 cars and the directions are right, left, stationary, left and left. So this is the infinite road. So this car moves to the right and this car moves to the left. So one collision happens here. The collision happens here, and since both cars are moving, the collisions count is increased by 2. So because of these two cars, the collision count is increased by 2. And after they collide, uh, they both will stop. So I can say these both cars are stationary. And after this, this car is moving to the right and this car is stationary. So this car collides with this car, and since one car is stationary, the number of collisions is increased by only 1. So here one collision happens, and after that, this car was already stationary. Now this car will also become stationary because of the collision. Next, this car, which has the direction left, is moving to the left, and eventually this will collide with the stationary car. And here the number of collisions will increase by 1. And after that, this car will be again stationary. And finally, the last car will also move to the left and collide with this stationary car. So this will also contribute to one collision. And at the end, this will also become stationary. So once all the cars are stationary, that means all the collisions are completed. So the total number of collisions is sum of all this, which is 2, 3, 4, 5. And we look at the second input. We have left, left, right, and right. So here, this car keeps moving to the left in the constant speed, and this car also keeps moving to the left, and this car keeps moving to the right, and this car also keeps moving to the right. And since the road is infinite, these cars will never collide. So this car keeps going like this. Car also in the same speed, and this uh, right, this car keeps going to the right, and same with this car with the same speed. So even after infinite time, they won't collide. So for this case, the output is 0. And for the constraints, the number of cars can be up to 10 power 5, and the directions can be only either left, either L, R, or S. Now let's go with the approach. So suppose we have the following example with the directions. What we'll do here is we'll iterate on the directions from left to right. And suppose we have iterated till here. So till this point, we'll calculate all the collisions that can happen so far. And after that, when we iterate on the new, when we check out the new car, so this car, we'll check whether this will have any collision with the previous collided car so far, and then update its state. And after that, we'll move to the next car and we'll do the same thing. We'll check whether this car is colliding with the previous state of cars so far. And based on that, we'll update the collision count and also the current state. So let's do a dry run on this example and see how we can do that. So for this, we can take a stack. So let's say initially we have the stack as empty. So there's a long road. And first thing is you have a car which has a direction of right. Now, so far, this car is moving right and there is no cars to the right side of this. So that means so far there is no collision. So we can simply add the right to our stack. That means whenever we have a right, we blindly add the direction to our stack and move on. So this is done. And next we have another car which is right. So note that when we are iterating on this car, so before doing this, all the cars which are added previously will have all the collisions completed. So when we are adding this R, that means in this stack, whatever is there, that is the collision state. So far there is no collisions happen. So this R is also added in the stack. Let's also keep a collision count. Initially it's 0. Yeah, so whenever we have a R, we simply add it in a stack. So two cars are moving to the right at the same speed. Now we are on the S. So here what happens is this stationary car. So since the current car is stationary, that means all the cars which is left of it, if they are moving to the right, they will eventually collide with the current stationary car. So what we'll do is whenever there is a stationary car, we will check in the stack whether the top of the stack is a car which has the direction of right. So here we can see that this car has a direction of right. So that means this car will end up colliding with the current stationary car. So we'll just iterate on the stack as long as the top element is R and increase the collisions. So first we'll pop this element and this is R. So collision will increase by 1. And next we will pop this R. And because this car is also moving to the right and this will also collide with the current car. So because of this R, the collision count is increased by 2 and then the stack is empty. So we stop. And once the collisions are done, we'll just add the current car state in the stack, which is S. Also note that in the stack, even if we have multiple stationary cars or if we have a single stationary car, it denotes the same because multiple stationary cars can't collide with each other. So as per the state, this should have been stationary, stationary, and stationary, but having a single S will be sufficient. So what happened is we have a S here. So we iterate on the stack as long as the top element is R. We keep popping it and increase the collision count. And at the end, simply add the current car, which is the stationary. So far what happened is, I'll write in the blue. So far this car has collided and it became stationary. This car also collided and this car is already stationary. So this is the configuration so far. Now the next car is again stationary. So now again we'll check whether the previous cars do we have any previous car which is moving to the right. But we can see from the configuration that all the collisions are completed and the last car so far is stationary. So we can directly add S to our stack, and this won't increase any collisions because the cars are already stationary and you're simply adding another stationary car. So the collisions will not increase. After this, again, you have a R. So whenever you have a R, you simply add it to a stack. Now there is a L. So when you have a L as the current car, so that means this car keeps moving to the left, and there are two possibilities of collision. Either there's a car which is stationary, so this car will go and collide with the stationary car, and collisions will increase by one, or either there is a car moving to the right, and this car will collide with this one, and the number of collisions will increase by two. So here we'll have two cases, but in this we are in the case two, that the uh, latest previous car is right and the current car is left. So in this case, what happens is these both cars collide and the collision count will be increased by 2. So the total collisions are 4. And this L will collide with R and it will produce a stationary car. So we can pop the R and we can simply add a stationary car. Also, before adding the stationary car, we'll also check whether in the previous ones we have any more R or not, because those R's can also collide with this S. But in this case, uh, once we pop the R, the top element is a stationary car, so there won't be any further collision. So we simply add the stationary car. So L and R has collided and it populated a stationary car, and collision count is 4. Now after this, we have another L. So here we are in the case 1. So there's a car which is moving to the left and it is colliding with a stationary car. Since it's a stationary, the collision count will increase by only 1. So collision count is 5. And L will collide with S and it will produce a stationary car again. So we can simply add a stationary. After this, we have a R. So we directly add R in our stack. Next, again R. So add it. Then again, we have an R. So again, add it in our stack. After this, we have a L. So again, we are in the case 2, that the current car is L and the top of the stack is R. So that means both of these cars will collide and the count will increase by 2. So first we pop this R and these both collide and the count will be increased by 2. So it count is 7. So once these both have collided, they will populate a stationary car. So we can say that we pop this R and these both have collided and the result of the collision is a stationary car. Now before adding the stationary car in our stack, we'll check whether the top of the stack still contains a car moving to the right, because we can see that this car is right and here a collision happened and it produced a stationary car. So eventually this car will end up colliding with this and this will also become stationary, and also the previous car is also moving to the right, that will also eventually collide with the stationary cars. So before adding this S to our stack, we'll check the top of the stack. So here we have an R. So we'll pop this R and increase our collision by 1. Again, we have an R in the top. So we'll again pop this R, increase the collision count by 1. And after that, here we have a stationary car. So no more collisions happen. And once that is done, we finally add our new stationary car into the stack. And after this, the directions list is exhausted and the total number of collisions occurred is 9. Now let's quickly code the approach. So first let me take a stack. And also we can take a variable which will count the collisions and iterate on the directions array or directions string. So here, like we discussed, if the current character is R, we will simply add it in our stack. Or even if it's the first car, then also we will add it in our stack. So we can say that if stack is empty or the current character is right. So in both the cases, we can simply do stack dot push the current character. So this is the case for R. Now let's proceed with the other cases. So next we have directions of the current character as let's say S. And then finally we have the last condition where the current character will be L. So these are all the three possible directions we can have. So now let's focus on the S. So we can see that the current character is S. So the top of the stack, if the top of the stack is let's visualize it. So the current car is stationary, and in the top of the stack, if we have a stationary car, then there's no point, like they won't have any collisions. Now instead of S, if the top of the stack is a L, then also no collisions will happen because this car keeps moving to the left and this car is stationary, so no collisions happen. So the collisions will only happen when the top of the stack is a right. So in this case, these both will collide and they will produce a stationary car. So we can say that if stack is not empty, first of all. So if stack is not empty and the top element of the stack is equal to R, in that case, there will be a collision. Collision plus plus. And then stack dot pop. But also we saw that if on top of the stack we have multiple R's and the current car is S, so all these cars, all the cars moving to the right will end up colliding with this S. So we can just convert this into a while loop. So as long as the top of the stack is a R, we'll pop it and we'll increase the collisions. And once all the collisions are done in the stack, we will just push the current character, which is S. So this is the case if the current car is S. So now finally let's move to the case where the current car is left. So in this case, again, let's copy this. So current car is left. So here also we have three cases for the top of the stack. If the top of the stack is left, so no collisions will happen because both cars will keep moving to the left. Now if the top of the stack is a stationary car, so in this case, there will be only one collision. So left will collide with this stationary car and it will produce a stationary car. So let's first handle that case. So we can say if stack is not empty and the top of the stack is a stationary car, in that case, collisions will increase by 1. And then we can directly, since top of the stack is S, there's no need to add another S in the stack. If we add also, there's no problem. So let's just add it for the sake of clarity. Stack dot push S. Now, uh, the left case is covered, the stationary case is covered. Now the final case is R. So that means the current car is left and the top of the stack car is right. So in this case, again, these both will collide and the number of collisions will increase by 2. And this will produce a stationary car. So let's just write that case. Else if stack is not empty and the top of the stack is a right. So in this case, collisions will increase by 2. And we'll first pop the element. We'll pop the top of the stack because they both ended up colliding. Now after this, when these both collide, they will produce a stationary car. But let's see what happens when we have multiple R's, like we discussed in our approach. So we have multiple R's here and current car is left. So here what happens is these both cars will collide and they will produce a stationary car. But we can see that the previous cars are all moving to the right and they can also collide with the current stationary car. So for that, we can just copy this while loop again. So once this is done, we'll check while the top of the stack is equal to right, collisions keep happening. So we'll perform that and we'll keep removing each of this R until the top of the stack is not equal to R. And when that is done, at the end, we'll just push the stationary car in the top of the stack. So this is the case if top is S. This is the case when top is R. And in the else case, that means the top of the stack is either empty or the top of the stack is left. We'll simply do stack dot push the current element. And at the end of the for loop, we'll just return the collisions. Right? Collisions. Here also collisions. Let me submit. Yeah, and it works. Finally, let's do the time and space complexity analysis. So coming to the time complexity, here we are just iterating on the direction string. And inside that, we are iterating on the stack. And each time when we iterate on the stack, like for each element, at max 2 operations can happen, either a push and either a pop. So in total, 2 n operations can happen. So time complexity will be order of n. And for space complexity, since we have created a stack, and suppose if the input is all right, then we'll keep inserting all of them in the stack. So the stack size will be, in the worst case, order of n. I also have the code in Python if anyone wants to view it. I'll add this in the description as well. Let's catch up in the next video.